Okay, so now we continue our discussion on costs and finish up on sunk costs. So we remind ourselves that sunk costs are costs that you pay upon entry, and these are costs that should be paid over the lifetime of the firm or sometime within the lifetime of the firm. Therefore, the firms must earn positive profits in subsequent periods of actual operations to cover entry costs. In the long run equilibrium, firms will stop entering the industry. Number of firms will be at an equilibrium level when the profit from operating each period just covers that initial sunk cost. Industry structure is likely to be concentrated in markets where sunk entry costs are a high proportion of consumer expenditures. So let's think a little bit about the sunk costs thing and how these sunk costs are related to a market structure. We also add here that the sunk costs that you are paying here also should include the fixed costs of operation as well. All right. So here we've got an example where you have E, which is price times quantity, and you have that the elasticity of demand is 1. Therefore, the expenditure will always be equal to some number E, whatever happens to price and quantity, because if price goes up by 1%, quantity will go down by 1%, so expenditure remains constant. Total market output, which is capital Q, is just N, the number of firms, times QI, each firm's output. And then QI is then just E divided by the number of firms times the price. So you're like dividing up the total expenditure by N. And you're dividing it by P as well to make it real expenditure or quantities. So the learner index for these identical firms is the learner index, which is P minus C over P. So these are all identical firms. So C is each individual's marginal cost, and it is also equal to the average C in the industry then. Assume that this declines as N increases. So you've got the price minus cost over price, the learner index, is equal to A, some number, but this number is falling because N is in the denominator raised by alpha. So break even requires P minus C times Q equals F. So again, F here includes both the fixed cost and the sunk cost that we're talking about. So equilibrium number of firms and E at which the entrant just covers its sunk entry cost F, which should really also include the fixed cost, is given by the following expression. And you notice that N and F are inversely related because F is in the denominator and N is in the numerator. Yeah? So that means if F rises, the fixed costs and the sunk costs go up, then you expect for a given expenditure, market size that is, and for the certain shape of alpha, then N will fall. Okay. So now let's talk about multi-product firms and costs. So from the start of this lecture, we were only talking about single product firms. And now the question is everything that we've been talking about so far extend to multi-product firms, firms that produce more than one thing? So the answer is yes, assuming, well, we'll find out in a bit what the restriction is. But we are using the concept called the Ray average costs from Baumol, Panzig, and Willer. RAC, Ray average costs. So this will measure average costs at each production level by keeping the output mix constant. Okay. So you consider a composite good Q, which is sort of the sum of your multi-products or your two products in this case, 1 and 2. So consider production along a ray. That along which the two goods are always produced in the same proportion. So Q1 is equal to lambda Q, Q2 is 1 minus lambda Q, where lambda over 1 minus lambda is the fixed proportion of the product mix along the production ray. Here I added a picture of this. So we consider the blue dot first, right? And this blue dot is a combination of Q2, which is on the y-axis, and Q1 is on the x-axis. And this combination is given by lambda. So you can imagine if lambda is equal to 0, that means all of your output is Q2. You're a single product firm of selling Q2, so the dot is here. And if lambda is 1, you're down here. Everything is in Q1. And if it's in the middle, it's some combination of Q1 and Q2. And the level of this line, you can think about this as an ISO production line or ISO cost line, right? And this line here represents a combination of Q1 and Q2 for a given lambda. Now consider changing the scale of production here, like from Q to another higher level called Q prime. So you're moving from this blue dot to this red dot, right? And consider this ray, this orange line, and this red dot. This red dot is produced at a higher production level. However, the ratio of Q1 to Q2, which is given by lambda over 1 minus lambda, is fixed because the lambdas are still the same, right? So moving up and down on this orange line is akin to moving up and down your total quantity produced. And it's on this ray, this RAC that we've called it, wherein average costs can be computed for multi-product firms. And in this particular case, we can draw it out for the two product example for a fixed lambda. Okay, so that's the message. We can calculate average costs if we consider expansions along RAC where the lambdas are fixed between products. So here we've got the total cost of producing both products at any level, which is C as a function of lambda Q and 1 minus lambda Q, where Q is sort of like a total production, that line, that downward sloping line we considered earlier, plus F, which is the fixed and the sunk costs. So now basically, the multi-product idea, which is on the left, Q1 and Q2, this could be Q3 and so on, Q4, Q5, is just the same as the single product idea, which is on the right-hand side. And the key here is that the lambdas are fixed. Marginal costs at any level are MC1 and MC2. So you have marginal cost for 1, marginal cost for 2. So the measure of multi-product scale economies is equal to essentially total costs divided by MC1 Q1 plus Q2 MC2, which is exactly the analog for the single product scale economies, which we discussed earlier. Okay. Essentially, this is average cost over marginal cost. And as we discussed earlier, if average cost is greater than marginal cost, then that means you have greater than one scale economies, okay, or increasing returns to scale. Okay, and then so on and so forth. Let's not talk about that anymore since we talked about that before. The key difference for multi-product firms is not just the scale economies part, but it's really, what's interesting here is the economies of scope. Whenever it's less costly to produce a set of goods in one firm than it is to produce that set in 2 or more firms. So in this 2-product case, you have the cost of producing 1. So here the lambda is equal to 1 because Q1 and lambda 2 is Q2 is 0. And then here is the cost of producing only firm product 2, and then you're adding them both because if you're 2 companies producing Q1 alone and Q2 alone, and then you subtract the cost of producing Q1 and Q2 jointly given a certain lambda that divides Q1 and Q2 at the same level, right? So that's the implicit assumption here, that this Q1 is actually equal to that big Q, or that Q, and then Q2 is equal to Q, and then Q1 and Q2, the weighted sum of that is also equal to Q. So that's why the total output is sort of held fixed. If the total output is held fixed, scope economies exists if the cost of producing each separately for that given scale, right, for that given scale, is greater than if you were to produce it together. Here's a measure of that economies of scope. So note that the numerator here is just the term up here, right? It's going to be positive if there's economies of scope. And it's divided by the cost of producing both together. So it's like a share of cost savings that you get by producing Q1 and Q2 for a given lambda and a given scale big Q, what the cost savings are for producing both of them together. So scope economies provides a central technological reason for the existence of multi-product firms. Two main reasons for scope economies: particular outputs share common inputs, and there could be cost complementarities in production. So likely becomes stronger following the introduction of flexible manufacturing system. Production units capable of producing a range of discrete products with minimal manual intervention. So different products versus different versions, likely that scope economies will be found when the goods being produced use similar production techniques, because more likely to find cost complementarities. Now, there's a distinction between different goods and different versions of the same good, because firms often market multiple varieties within a product category. It is useful to model markets in which the basic good is sold in many differentiated versions. If scope economies exist, firms have strong incentives to exploit them. With multiple varieties in a category, the implication is that firms in such markets ought to produce a wide range of product types. So if scope economies exist, we should find this fact that there's a wide variety of product types within a single firm. The presence of scope economies as identified makes it possible to exploit the multi-product scale economies. So examples are spoke and hub systems of major air carriers. Multi-product scale economies can only be realized by operating in both the spoke and the hub markets. Significant scope economies lead to more concentrated market structures in two ways. It creates incentive to consolidate the production of different products because it's cheaper to do that, right? We've just seen the scope economies argument. And different product versions within one firm rather than in separate firms because of it will lead to lower costs. Give rise to important multi-product scale economies, leading firms to be relatively large relative to market size, which would give you this increasing returns to scale thing that we discussed about earlier, that if the minimum efficient scale is large relative to the size of the market, fewer firms will probably be present. So next, let's talk about learning by doing and experience curves. So the total cumulative output over its entire history may influence a firm's costs. So the more you produce, the longer you've produced, will most likely tell you that you know how to produce it, and therefore that will push down the average cost curve. Firms can also forget. So if you forget to produce or produce at a smaller scale, then you'll forget insights, and that could raise your average cost. So learning by doing could lead to concentrated market structures because it provides further advantage to first movers or early entrants. Strategic considerations are likely to reinforce this result. Incumbents may price strategically low so as to sell more units. The prospect of forgetting what it has learned gives the incentive to price low and thereby acquire more experience. So learning by doing will likely lead to more concentrated markets. So precisely for the same argument that average costs are falling and therefore the minimum efficient scale is also rising relative to the size of the market. So all of these things that we've been talking about, economies of scale, economies of scope, learning by doing, essentially means that if one firm produces more output, more products, produce longer periods of time, then their average cost is smaller, lower relative to everyone else, and therefore it is possible that the market can only have or receive, can only profitably have a little small number of firms. So we'll move on from MES for now. This is a related topic, but this is called the non-cost determinants of industry structure. So to differentiate it from the earlier discussion, we talked about average costs in the earlier discussion, right? And things that move down the average cost or shift the average cost down. This time we'll think about the size of the things that are not directly cost related, such as the size of the market, the presence of demand-side network externalities, and government policy. All right. So market size and competitive industry. So a large firm in terms of MES does not necessarily imply a highly concentrated structure if the market is large enough to accommodate many such firms. So the larger the market, it's more likely that the market size is large relative to MES. Relative relationship between market structures and market size will vary according to the specific market being examined. If scale economies are exhausted at some point and if sunk entry costs do not rise with the size of the market, then concentration declines as market size grows sufficiently large. So if you can see here, there's an if here, if sunk entry costs do not rise with the size of the market. Or more generally, if fixed costs do not rise with the size of the market, then concentration will decline. But what if serving or working in a larger market means higher fixed costs and higher sunk costs, right? So that's exactly what Sutton was thinking about. It provides a Sutton 91 in 2001 provides a qualification to the idea that concentration will decline with the size of the market. So his idea is that the fixed cost here is a function of A times E, which is the expenditure in that market. So the bigger the market, the more expensive it is to enter and survive in that market, basically. Okay. So the equilibrium number of firms, this is similar to the other discussion, simply that N is now related to E, or expenditure. Okay. So in this case, the equilibrium number of firms will grow as the market size AE grows, but that this process has an asymptotic limit, which means that N does not grow forever, but N will reach sort of this limit, 1 over beta over 1 over 1 minus alpha. So instead of firms becoming very numerous as AE goes up, there's a limit to the number of firms that can come into the market under this condition. So that's what that's the Sutton idea, basically, that if fixed costs are related to average, the market size here, AE, and then it's beta here. That's very interesting. The beta is that coefficient, right? As long as fixed costs don't rise linearly like this, and it doesn't rise too high, then yes, it's true that the number of firms will still grow as AE grows, but there will be a limit, as opposed to this not being the case. As AE grows, then there's no limit to the number of firms that can come in. It will just go up and up and up. Right? And that's the main message of Sutton. Even these sort of linear constraints, a relationship between F and expenditure here is enough to basically cap the number of firms. Next is network externalities. So network externalities reflect that for some products, a consumer's willingness to pay for a good or a service increases as the number of other consumers buying the product rises. So there are direct network effects, which is usefulness or value to a single consumer is 0, but as more people sign up, the number of users and hence the utility of the service increases as well. So these are called direct network effects, where you look at the total number of people in the network, and that will tell you how useful it is to you. Joining the network is to you. There is an indirect network effect, which are complementarities with other products, such as apps made compatible with the operating system. And consumers want to make the operating system for which the number of applications is the largest. So indirect network effects is more of complementarities with other products. Markets with large and significant important network externalities are likely to be the ones populated by very large firms. So examples here are these network platforms, communications platforms, wherein the number of people within the network is very, very important. Might talk about network externalities a little later in this course, because there's more detail here. This is a correct description, but there are interesting side notes here regarding network externalities. In particular, as it relates to, say, transaction platforms versus non-transaction platforms, etc. All right, and finally, you've got the role of government policy as a non-cost determinant. So explicit government policies often play a role in determining market structure. So sometimes there's a cap. In the Philippines, for example, there's a cap in the number of TNVSs that are it's possible to operate in the Philippines. The cap in the number of drivers, supposed to be, right? There are caps, there are policies regarding subsidies and taxes that often help smaller firms or help firms that are very strategically important to the country, right? And finally, of course, there's antitrust, which we seek to prevent mergers and acquisitions that increase market power. So these are some non-cost determinants of industry structure. Okay, and then after this, there's still another lecture on cost and technology, which I'm quite excited about because it sort of dovetails with my own literature, with my own research. All right, I'll see you there. Bye.